टक टक आवाज आती है या दर्द होता है इस
Good evening to everyone.
Good evening, sir.
Good evening, sir.
Okay. We'll see what is GPS and what is DGPS. What is the difference between these two? GPS, that is known as global positioning system, and DGPS, that is differential global positioning system. Differential GPS. global positioning system. These are GPS and DGPS. The carriage requirement, it is again given in the SOLAS chapter 5. So these all are the navigational equipment. SOLAS chapter 5, regulation 19 and para 2.1.6. So it says that all ships irrespective of size to have a receiver for a global navigation satellite system. This is known as a GNSS or a terrestrial radio navigation system. This terrestrial navigation system, this is still in use. If the ship goes for the Arctic region or Antarctic region. Okay, so they still use this terrestrial radio navigation system. Suitable for use at all times throughout the intended ways to establish and update the ship's position by automatic means. Now let's understand what it is saying. So basically GPS and DGPS, it is mandatory requirement for all ships. Whatever the size is there, this is supposed to be fitted. Okay. So this GPS and DGPS, what we are saying, basically it is known as a Global Navigation Satellite System, GNSS. GNSS. Or a terrestrial radio navigation system. Olden days, this was used. Nowadays, it is discontinued because of the GNSS. So, but it is used when the ships are going to the Arctic or Antarctic region. In that case, this is still, it is in use. Okay. Now, next, what it says that it's supposed to be used all the times throughout the voyage. It's supposed to be there, and automatically it should update the position, ship's position by automatically. So automatically updation should be there, ship's position. Now here the word has come. It is not saying GPS, but it is saying GNSS. So basically, this GPS is GNSS only. There is the actual name that is known as a Global Navigation Satellite System. And the name given GPS, this is given by the US because they have invented this one first. So this is invented by the US. That's why they have given their own name that is known as a GPS. Same like Russia is also have given, they have also invented their own, and that is known as a GLONASS and D-GLONASS. EU, they have also developed their own GNSS EU, European Union, and they have named it Galileo. Japan is also having its own GNSS, and that is known as a QZSS. China has also developed, and that is known as a Baidu. India has also developed its own, and that is known as a Navic. Like, okay, so like this, make some countries has already they have developed their own. So these all are known as a GNSS. Okay, these all are known as a GNSS. This is the name that is given by the country. So if we are going to understand, because the oldest one in this is the GPS. So if we understand this GPS and DGPS, we can understand all other how it is working. So let's see what is the GPS. So first of all, we need to understand the GPS. GPS, it provides position, navigation, it helps in navigation and timing. This is also known as a PNT. PNT. Services to users. Okay. So it provides the user's position, navigation also in which direction we are going, and the timing services. Okay, so navigation. So this all GPS is providing. So this is the end user, but how it is going to be? So we have a satellite. So minimum 4 satellites are needed. So suppose there is a 4 satellites are there. Satellite 1, 2, 3, 4, 4 satellites are there. So this is minimum satellites. So these all are known as a space segment. Space segment. So there are total for the GPS, every country have their own 24 constellation of satellites are there. So 24 satellites that is used as a space segment. So any given point of time anywhere in the global, minimum 4 satellites will be visible. Okay, minimum 4 is always visible. Now what these satellites do? This satellite, suppose here this is the ship and user, and we have the antenna here. They are going to send signal. They all are sending the signal to the user antenna. Here, like this, it is coming. So this is the user segment. This is the user segment. Now, what they are sending, that is important again. What they are sending. They are sending two things. One is their orbiting data, that is known as a satellite orbiting course of, means orbiting, because they are orbiting. So whenever they are going to send, they are sending their orbiting coordinate data. The orbiting coordinate data they are sending. So this is the position of the satellite at that particular time because it is orbiting. So it is sending. Plus time stamp, because timing is important. At that particular time, this satellite was here. So timing has to be there. So this is known as a timing stamp. So along with the data, timing stamp also should be same. Without timing, we cannot calculate. Okay, or the error will be there. So timing stamp is necessary. So all these four, they are doing this, they are sending. Now the user segment or this is a GPS receiver. Many people are thinking it is a trans receiver. That is wrong. Okay, GPS is only the receiver. It doesn't transmit. Okay, so GPS receiver, that is the user. User segments collect this data and it is calculating. The calculating method is known as a triangulation method. Triangulation method. Triangulation, because all the three coordinate, we need to calculate this one. That's why tri means triangulation. So triangulation method, that is how it has come. So this triangulation, it is going to calculate and find out the lat and long, its own position. Okay, lat and long of ship on position. So ship is finding lat and long by the data sent by the satellite. Now you will think that data, that is the satellite which is sending, it is sending their own positions. Then how we are going to calculate that one, how we are getting. I hope everybody has studied the coordinate geometry, and when the GPS was not there, that time we are taking or we are calculating our own position by coordinate geometry. I hope everybody has studied that one. So there is a x-axis, y-axis, and suppose there is a 2 point is known in this one. They are the known point, suppose point 1 and point 2, they are known. We can calculate the third point, this position. The position of the third point we can calculate if we are knowing these two positions. This is known as a taking a fix or fixing the bearing. And that is the reason how we take the fixing. Fixing the bearing means we are taking the bearing. And if you are seeing the object positions if we know, then we can find out our own position. So in that case, we are taking the like sun position, moon position, because these all are calculated and it is known because this chart is given to the navigator. They are knowing at this particular day, at what is the time for the sunset or sunrise. They are knowing each and everything. So what is the position of the sun and moon, that is also calculated. Once we are going to take the bearing of that one, we can fix the position. Okay, although it is a movable position, but we can fix and we can find out our own position. So this is how it has been developed from this coordinate geometry to all the three directions, because it is in all the three axes we need to find out our positions. And that's why this is known as a triangulation method. So that is the name has come. So it is simple because they are providing their own positions. Here we have to take a fix and find out their position, and thereafter we calculate and find out our own positions. Okay, so same thing here is also happening. This all our things are orbiting, but they are transmitting their own own positions in the orbiting path in the space with the timing. So it's a very easy to calculate the receiver, and it is going to determine their own position because this is something like a fix. So if three known positions are there, we can find out our own position. Okay. So this is the space segment and user segment. There is one more segment is there in this one, that is known as a control segment. That is known as a control segment. So this is the B, and there is a C. This is known as a control segment. This control segment basically it's monitor worldwide. These control stations are about 6 or 7 are there in the worldwide. 7 position, I think 5, 6 or 7 are there. Say 6 or 7 position control station is there. So this control station, they are continuously monitor the orbiting path, then they adjust the orbiting path of satellite. So their proper orbiting path, they are going to adjust. And they also monitor not only the orbiting path, but the clock is also important. So satellite clock is a nuclear clock. So the accuracy is very, very high. So they are going to monitor this and adjust also if sometimes it is required to adjust because everything depends upon the timing. Okay, so like this, they are continuous. So control station is going to do only this work. So that's why we can divide into the three segments. One is the space segment, user segments, and the control segments. So basically, if you say like there is a space and we are the user, if you bypass the control segment, it will do. There is no issue in that. But they are also part of the everything because they are going to monitor, adjust if satellites are diverting in the orbital path. In that case, they are controlling that. Okay. Now, what is the differential GPS? Differential GPS. differential GPS that is there, it is in the user segment. Now, suppose in the light, you might have studied something is known as a refraction. I hope everybody know about this refraction. Okay. If one layer are changing, then there is a refraction is there, and refraction it depends upon the angle of incident, and it is going to refracted. The beam that is or light is going to be refracted. So refraction, there is a one word. Now when the signal that is coming, although it is a light signal, but light signal also is going to refract. Refraction will be there because in the atmosphere we have the layer, different layers are there. Due to that, there will be a refraction. Due to the refraction, the timing that is going to change if the data, one is coming directly and one is coming after the refraction. If suppose there is a reflection and there is a refraction, so there is two things. Now I will talk about the reflection. Now what happens, suppose this is a sea and very calm sea is there. Generally it happens with the radar, and if there is a ship is there in this position. So what will happen? The transmitted waves, it will, or receiving waves also, not only the transmitting. Suppose the receiving waves which is there. Suppose there is a transmitted waves that has gone, but the receiving waves which is coming, if it is going, it will be coming, one is going to come directly, this will reach before only, and one that is going, because this will act like a mirror. If she is very calm, then it acts like a mirror, like this. So if you see the timing of this one and this one is changed, this is due to the reflection, mirror reflection. Okay. So here the timing of this signal which is reaching, this is also reaching, and one this is also going to reach. But this is going to create one error. It is going to create reading error. So reflection and refraction, these two things that is going to create the error in the GPS receiver which is receiving. Refraction, like suppose take a bucket of water. So there is a two media here. You put a rod in this one. You might have seen these all things with the, in the physics it is there. So this shows like a bend. This anything if you are putting, it looks like a bend. It is bending. Okay. Due to the light refraction. So this is known as a refraction. So reflection, refraction, if there is a nearby hilly areas are there, hills are there, or suppose it is near the city, high-rise buildings are there. Or there may be some regions, other regions. Okay, due to that, there is going to be some reflection, refraction. then this is going to cause the error. Because two signals are reaching, time stamp is same, their data is same, but timing of reaching is different. Because from here it is transmitted and from here the reaching is different. So the distance what it is calculated by this one and this one will be different. Okay, so basically if you see, we are calculating the position of these spaces, these space segments. And accordingly, we are calculating our own position. So this is taking a fix basically in the space and we are calculating. But the data which is transmitted, if it is not correctly coming, then it can give the error. Now, how to avoid this error? So DGPS, this is having two receiver. It is having two receiver. One receiver is GPS receiver as usual, and second is the beacon. There is the beacon. This is the one antenna. So this is going to receive beacon receiver the signal. This is also receiving the signal and this is also receiving the signal. GPS, this is receiving the signal from the space segment, whereas beacon, this is receiving the signal from the reference station. Now control station, what I have told you, that is different. This is a reference station. Reference station, this is located in the coastal. Okay, so this reference station, their location in coastal. This is also known as a surveyed location. Regularly, the survey is done. This survey is being carried out by the integrated monitoring equipment, integrity monitoring equipment. And after this one, this surveyed location or reference station, they are having the transmitting towers. So these transmitting towers send the corrected data to the user segment. That is the GPS. So it is going to send the signal to the GPS, and this is known as a corrected data. Because they are going to survey the area, they know that at this particular position, this should be the data. But if the data is not same, that means there is some issue and that is being corrected. And after that, the corrected data is sent to the user segment. So again, it is having the three segments. It is having like reference station, that is the one. Second, that is the surveying or surveying equipment or integrity monitoring site. And third, that is ourselves, that is the user segment. So reference station, this is having a transmitting tower and which is going to send the signal all around. Whereas serving equipment and integrity monitoring side, they are going to do continuously monitoring of the data and they are going to correct the data and send to the reference station. So this is the corrected data and this will be sent to the reference station. Reference station is going to relay same data. So if the ship which is going to receive that one, so it is having the two information. One is already it is having the GPS receiver signals from the space segments. And if any error is there, if any one of or two of the satellite, then that data is also coming. So now, if it is going to calculate, so accuracy is going to increase. So the accuracy in finding lat and long, latitude and longitude of on position. So this increases. So accuracy is going to increase. If it is increasing, of course, if like it was a 10 meter with the GPS, accuracy will come at least 0.1 meter, 0.2 meter. Likewise, the accuracy that is going to increase. So this is the difference between the GPS and DGPS. Now onboard ships, what it is fitted. So that is important. Onboard ships, the fitment is DGPS only. Both are the DGPS that is put. We can select DGPS 1, DGPS 2, any selection we can do about this one. Okay, and this is the block diagram of the DGPS. So if we say GPS, if we say DGPS, generally onboard ships, there is no GPS, it is the DGPS only. Okay, but it is having the GPS antenna also and it is having the beacon also. So it is going to receive the signal from the reference station, that is the corrected data. It is also going to receive the information from the satellites, space satellite. We can do selection either the GPS 1 or GPS 2. And these all equipments are given the data. So it is interfaced with this all equipments and it goes to that. Okay, so this is about the block diagram. I think very simple block diagram is there. Signal will be going either through the NMEA signal or Ethernet. Some of the ship they are using the Ethernet. Some of the ship they are using the NMEA. NMEA signal supposed to be used as per the IEEE, that is marine related any data communication between the equipment, there should be the feasibility for the NMEA signal. Okay. I hope everybody know about this full form of the NMEA. Okay. Next is anemometer. Let's see about this anemometer. Anemometer, they are having one display unit, and second it is having the sensing unit. It senses the wind speed and directions. So this is the sensing unit and this is the display unit. We generally say sensor. Now, these all are the old type model. Now also it is being used, and this is known as a windmill type sensor, windmill type sensor. So it is going to give the direction. So this will rotate 360 degree. Here it is going to rotate 360 degree like this. So if it is going to rotate 360 degree, this gives the direction of the wind. So this is going to give direction of the wind. This one is going to rotate. That is the fins. If this is rotating, this is going to give the speed. Speed, wind speed. It will give the wind speed. So here simply there is a dynamo that is fitted. Dynamo you can say, or you can say a generator, a small generator that is fitted. So this is the AC generator that output goes. So basically this is a generator. This is the AC generator. DC generator generally we do not use because of more there will be the issues with the DC generator. So generally the AC generator that is used, it is having a slip ring. Okay, so that arrangement is much more easy than the DC generator. DC generator will be having the commutator. So frequent maintenance that is required. So this basically this AC generator, so this is going to give the output to this voltmeter. This is basically a voltmeter. It will convert it into the DC by rectifier and it is going to show the voltage. So this is a DC voltmeter. DC volt. So how much speed this is generating, that much the generator is going to generate the AC voltage. It will be given through the rectifier to this and it is going to display. So that is meter per second. Here, because this full arrangement, this windmill, this is going to turn around when the direction is changing. So below this here, we are going to have the synchro. I hope this synchro already I have told you during the main engine telegraph. So this is a synchro transmitter. This synchro transmitter, this will be given to here, and this is known as a synchro receiver. Synchro receiver. So this is how, this is very simple system. One, we are going to have a generator and here is a voltmeter, whereas here we have the synchro transmitter and here it is synchro receiver. So it is going to show 360 degree, whatever the direction is there of the wind. Okay. So this is anemometer. Okay, got it, everyone?
Yes, sir.
Now, next we will see the speed. That is the speed one. This question was also asked speed and depth. Okay, then I will take this GMDSS just after the break. I will be taking. This is again a good important one. Let's see about the speed sensing devices. So speed log. Speed log. Speed log. This is of two types. One is known as a EM log, and second is known as a Doppler log. Both are used on board ship. Both are having their own advantages and disadvantages. Now, EM log, when we are talking, this is also given in the carriage requirement. So any speed log that is given, even the echo sounder, so it is given the requirement that is in the SOLAS chapter 5, regulation 92.3.4. This is the paragraph. Okay, what it says that all ships of 300 GT and upwards and passenger ships irrespective of size shall be fitted with point 1 and echo sounding device or other electronic mean to measure and display the available depth of water. Available depth of water. Point 4. Speed and distance. Speed and distance measuring device or other means to indicate speed and distance through the water through the water. Okay, so it's very clear. One is we supposed to have the echo sounder, which is going to measure the depth and display also. And we supposed to have the speed measuring device, speed and distance measuring device, which again it is going to indicate the speed plus the distance through the water. Okay, so this is the regulation for speed log and echo sounder. Now, when we say about the speed logs are again, it is two types. Speed lock. So speed locks are two types. One is the EM lock. This is the short form of electromagnetic lock. Electromagnetic lock. Electromagnetic lock, this is governed by the principle that is Faraday's law of electromagnetic induction. Electromagnetic induction. Electromagnetic induction. So how the induction is being done, that is induced EMF, that is the same. Okay, so similar way, this is also going to produce the induced EMF that is being sensed and it is given. Now induced EMF, we have the one formula, and that formula is E, that is the induced EMF, is beta, length of effective length of the conductor, the velocity it is moving, and the sign theta. Where theta, basically this theta is the angle between V and V. V is a direction of conductor. So that direction of conductor and the direction of the flux. So that is the angle. So if suppose this is the flux direction here, and suppose we have the conductor, there is a conductor, and conductor is moving like this in this direction. So this is going to be the angle. This angle is theta. So there is the velocity, there is the direction. A is conductor, A is conductor. And here the beta, this is the flux density and that is the direction. Okay. Now, how we do this one on board ship, how we find out. So we are going to have a we have to have a magnetic field. That is the first and foremost thing. So magnetic field, we required a winding or solenoid, you can see here, that is the same. So electric winding is there, in that we are going to pass the current. So a magnetic field that will be produced around it. So this is the magnetic field, you can see that is produced in it. Now magnetic field is there. This is mounted on the ship and ship is moving. So there is a motion of the magnetic field itself. So there is a relative velocity between the magnetic field and the conductor. What is conductor here? Conductor is being the seawater. Seawater is a conductor. Okay, seawater. So seawater is a conductor, and this is mounted at the hull of the ship. Like this. This is mounted here in the ship. Now, If this is moving, this is having a velocity, that is the V. That means magnetic field is moving. So there is going to be a speed, relative speed between magnetic field, that is the V, and conductor. Conductor will be in the opposite direction, 180 degree. Okay, so both are aparting, basically you can say, and conductor. That is the A. So A is there, sea water. Now if in the sea water, if it is going to induce the EMF due to the relative speed, so induced EMF E will induced in the water. E will induced in the water. Induced in the water. Now we need to have a pickup, because how we are going to measure the seawater. So seawater, in that we put two pickups. One pickup is here and one pickup is here. So around this we measure the voltage. So this is going to give a voltmeter like this, or it is already shown here, you can see. So if we are going to put one voltmeter, EMF measuring voltmeter, so it will show the reading here, how much the voltage is there. Now this voltage generation is entirely depend upon the velocity of the ship. That means relative speed. Here the theta is fixed because it is moving in this direction and it will be in this direction only. So if you see here the theta is going to be 90 degree and it is maximum, because ship is moving in this direction. So conductor relative velocity will be opposite, other side. So now if you break this one, or E, like B effective length of conductor and sine theta, because it is 90 degree. So these all are the constant we can present with the K. Only variable is the V. That means the induced EMF E is directly proportional to the relative velocity or speed of the ship. So induced EMF, how much the EMF will induce depends on induced EMF depends on the speed of ship or velocity speed of ship. So we can determine that what is the speed of the ship. How? Now suppose our EMF here generation is suppose 0.1 millivolt. Just randomly I am saying. Okay, 0.1 millivolt. Or why to take like this full accuracy? Well, okay, we'll say like 1 volt, just for example. So 1 volt is 1 knot. Okay, nautical mile, 1 knot. 1 nautical mile per hour, 1 knot. 2 volt if I am getting E, that means it is a 2 knots. 3 volt, 3 knots. So likewise, if the how much the EMF I am getting, I can calculate proportionally how much the speed of the ship is there. The speed of ship. If the speed of the ship is known, that means how much the distance I have covered, I can calculate that. distance. Because if the speed is given, now ship is starting time I know it, and thereafter, after reaching to the destination or 24 hours or the timing, okay, that I know. So suppose after 24 hours I know how much the distance ship has covered. We can calculate that one because we know the speed of the ship. Even the speed of the ship is variable, that can be calculated. The distance can be calculated. Okay. So this is how the speed log, that is not only gives the speed of the ship, but it also can measure the distance of the ship, how much the distance ship has covered. So the sensor which is there, how it looks like. So the arrangement of the sensors is like this. It is having a small cover. This cover is basically very, very strong, but the magnetic field can go out of this one. So this is also known as a dome, D-O-M-E, dome. Dome, it is a very strong material and it is covered, but the energy can travel through this out. Okay. So this is known as a dome or cover, especially you can say especially designed cover. Inside this we have the solenoid. On the outer side of the dome, we are going to have a pickup here. A pickup sensor which is touching the water in the port side. Starboard side also we are having a pickup that is touching that side of the water. So this becomes a effective length of the conductor from here to here. So this is fixed. So your L is fixed. How much the magnetic field is there? So that beta is fixed. Okay, sine theta because it is perpendicular to the water here. And if the ship is moving in this direction, it is going to remain same. So sine theta does not change. So it is also fixed. And this is how the induced EMF is directly proportional to the speed of the ship. And we can find out what is the speed of the ship if we know how much the EMF it is generating. How much the EMF it is generating. Okay, any doubt to anyone? This. Okay. After the break, we'll see the Doppler law. Okay, so we'll start. Then tomorrow we'll start. Not tomorrow, today also about the GMDSS. Again, one of the important one. GMDSS. I will try.
Sir, this coil is supply power supply given to coil.
Power supply given to.
Coil and this coil is inside. Coil is there.
Yes, yes, it has to be given.
How
That
much?
that is 100 volt, 110 volt. As per the
Okay.
log, how much the log is there? If it is of 24 volt, it will be given that much. So it depends upon who is the maker and how it is given. Sometimes,
Normally, this located in forward. Na, sir?
sorry,
This located in forward location.
location, no, no, it can be anywhere, but generally EM logs are in the forward section. Generally, it is there, but it can be put anywhere in the ship's hull, bottom of the hull.
Okay.
Okay, have a break of 5 minutes, then we'll start.
Okay. Sir.
Okay, now let's see about the Doppler law. Doppler law is also used to find out the fifth state. So here working principle is Doppler effect. Doppler effect. It is a very Doppler effect is known from very ancient period. This was known, or this is also it is also known as a Doppler shift. It is also known as a Doppler shift. What is Doppler effect or Doppler shift? It is the apparent change in frequency or wavelength. Wavelength I am writing lambda of a wave for an observer and source having relative motion. Now here also there is a relative motion, and as per that it is what. So due to the relative motion, the frequency or lambda will change. Now there is a relation between lambda and frequency. Lambda is equal to C by F. C is here. Here the C is a sound frequency because we are going to transmit the sound wave in the water. So this is the sound frequency in water. In water. Sound frequency in water. Or sonic wave in water, sound wave in water. Oh, sorry, sound speed, sound speed in water. So sound speed in water is approximately 1500 meter per second. Approximately. Okay. So this is 1500 meter per second. Not in the air. Air is different, it is less. But in the water, it is 1500 meter per second. And this is the frequency, this is the sound frequency. So as per speed and frequency, we can have the lambda calculated. So basically, lambda and frequency is inversely proportional to each other. That is not an issue. If you calculate the frequency, we can calculate the lambda also. But what it is saying that if there is a relative motion between the 2 point means one that is the source and one is the observer. This observer, if it is moving or source is moving or both are moving, okay, there is going to be the apparent change as per their relative motion. So relative motion can be two. What could be the relative motion? Now suppose here we have a source. This is the source. Okay, I'll make it down. If there is a source here, suppose this is a source. This is a source of the sound. Okay, and here we have one observer. Okay, suppose this is the observer we are having here. Now, if suppose this source is moving this side, It is not moving, but this is moving, or this observer is moving this side, or both are moving. This is known as a closing. It is known as a closing. So when they are closing, any one is moving towards each other, then they are closing, or they are moving in the opposite direction. Now suppose if this is moving in this direction or this is moving in this direction, both or any one, that is a parting away. A parting away. In both the cases, there will be the change in the frequency. So this transmitted frequency, if suppose this is the FR, this is the transmitted frequency of the sound. If this is the FR, this is reaching to the observer. So this is the, oh sorry, this is the transmitted frequency, that is the FO, and which is reaching to the observer. This is the FR. So we can say that if there is a change in this one, this is the movement, due to the movement, because they are closing or are parting away. So this is the relative motion. So due to this one, so if it is closing, then FR is going to be FO plus FD, where FD is a Doppler frequency. If it is the parting away, that means the FR is equal to FO minus FD. FO minus FD. So this is the two formula that is being used to calculate the Doppler log. Doppler log, this is going to work in this. So FR, that will increase because they are closing. Anyone, if FO or the observer means the source or observer, anyone is closing or both are closing, there will be change in the frequency. It is going to increase. Frequency will increase. In this case, if they are a parting wave, frequency is going to decrease. So this same thing we can write here. Same thing we can write here, that when the source of the waves is moving towards the observer, I am writing only one. Source of waves or the observer, anyone is moving, okay, or closing to themselves, then in that case, the wavelength lambda bunches together. This bunches together. So if it is going to bunch together, becomes lambda becomes shorter. And if the lambda is going to become shorter, that means the frequency become more, or it is going to increase. Lambda is shorter means frequency will increase. So we can say if A4 is transmitted frequency, if A4 is transmitted frequency, FR is received frequency by observer, then and also FD is a Doppler frequency due to Doppler effect. So how much change is going to be, that depends upon the movement. But the relation will be always same, that is the FR is equal to FO plus FT. So how much the FD will be there, that is depend upon their velocity. So FD also have the formula for that FD. So FD also we can calculate with this. And FD is given by FD. There is a separate formula for the FD. 2FO, 2V is the velocity, relative velocity, FO cos theta upon C. So this is the formula for the FD. So we can, if we know the FD, we can calculate the velocity. Okay, if we know the FD, how much the FD is there, we can calculate the velocity. So that is exactly what we do here. So there the FR is equal to FO plus FD. The opposite is also true if they are aparting away. So we can say conversely, if the source of waves is moving away from the observer, or observer is moving away from the source. Okay. The wavelength lambda is spreads out. Lambda is spreads out. So longer wavelength, longer lambda has a smaller frequency, because frequency will decrease if lambda is going to increase. So you can see here like FR is equal to FO minus FT. So this will be relation if any one is aparting away, moving away. This is going to be the relation. Now how we find out what is the FD, how much the FD is there. So that is the important thing. So there is a configuration to send the sound energy, and that configuration is known as a Janus configuration. Janus configuration.
Sir,
Yes.
sir, what will be the observer? I mean, source is from the ship. Then the observer is
Sorry.
by this method we will know that source is from the ship, and what is the observer, sir? I mean receiver to send back.
No, I'm coming to that one. Just wait.
Okay.
Okay. So we are going to find out the Doppler, and for that we are sending the energy, sound energy, in 4 directions. This is known as a Janus configuration. Okay, this is a Janus configuration. So at the 60-degree angle, we are sending in the forward port, starboard, and aft. Port and starboard, this is to neutralize the roll and pitch effect. That's why this port and starboard. But forward and aft, what we give, send the energy, okay, and when it is going to return back to the receiver will be here only, the transmitter and receiver. So when it is returning back, by the time ship is already moved, it is moving because this is the direction you can see of the ship. So for the forward, now already this ship has, suppose it has moved, by the time this energy is coming back here. Okay. So if the energy is coming back, it is going to already move here. But by the time this energy is coming back, it is taking a long time, very long time. That means here in this case, from the aft, it will be calculated like Fr is equal to Fo minus Fd because it is something like moving away. Whereas the return frequency here, this Fr, this will be calculated like Fo plus Fd. Why? Because the frequency of this one is going to increase and the frequency of this one is going to decrease. Okay, it will increase here and it will decrease here. These two are sent into the comparator circuit. When it is sent to the comparator circuit, then we can find out how much the FD is there because the transmitting frequency will cancel each other. So it is something like this here. So this is the aft and this is the forward beam and this is the receiving one. So this receiving, it is basically closing together, whereas this one, the distance of this one is going to increase. If you see here, this is the transducer and this is also having the receiver both. So this is a transducer, that is transmitter plus receiver. Both are housed together. So if we are going to put this one to the comparator, in the comparator, Ft minus Fo minus Ft. So we can have the 2 Ft. Now Ft formula already we know it. We know the FD formula that just now I have written. That is the 2V F naught cos theta upon C. C is same is speed of sound wave. Theta, that is the angle we are sending this beam. And this angle is also fixed at 60 degree. You can see this is the 60 degree, it is fixed. So it is not going to change. Always the angle, this theta is going to be 60 degree. This theta is going to be 60 degrees. So this energy always sent at the 60 degrees. So this is fixed. So it is not going to change. So what all things are constant here? If you see that the constant value we have, that is the K into V, we can write this one like this, where we can say the K is 2 F naught cos theta by C. These all are constant value. They are not going to change. The speed of the sound, transmitting frequency, the angle of the beam which it is being transmitted, these all are fixed. That means how much the FD is generated, this solely depend upon the velocity of the ship. Velocity of the ship. So we can say, like if the FD, Doppler frequency, is suppose 1 Hertz, okay, and if it is for the 1 knot speed, so this FD, if it is 1 Hertz, that means we can assume the speed of the ship is 1 knot, same like 2 Hertz, 2 knots, same way 10 Hertz, 10 knots. So we can find out the frequency FD and how much the FD is there. As per that, we can determine the speed of the ship. Okay, or velocity of the ship, we can find out. Okay. So this is the Doppler log. So this is the Doppler log, this works. Doppler log, their frequency it is transmitting is 1 megahertz. So A4, here the A4 which is being transmitted, it is 1 megahertz in the Doppler. A4 is 1 megahertz. Any doubt in this? Now let's see about the echo sounder. Echo sounder, this measures the depth of the water. How much the depth is there? Working principle is same like a radar, but here instead of the RF energy, we are having the sound energy or sonic energy that is known as. So again, we are having here the pulse. This is again pulse modulated or pulse modulation is there. Without pulse modulation, we cannot find out the range or depth or distance. So pulse modulation is necessary. This is important. Always we are going to have the pulse modulation. So that pulse is sent to the seabed, here the seabed, and it is reflected back from the seabed. The timing is being count of the pulse which is returning back. So we can measure the depth. The depth D is equal to half of velocity of the sound, that is 1500 meter per second approximately. And the time taken, how much the time it is taking to going to the seabed and coming back. So we can measure the depth. So we are transmitting and returning of the acoustic pulse. Here again it is written pulse, means pulse modulation, same like radar. So we are going to have the pulse. This is the transmitting pulse. This is the periodic pulse, and in between that there is a reception time. Receiving. How much time it takes to receive, that will give the distance. Okay, so this is how the echo sounder works. Name itself echo. The echo has to return back from the seabed. And sounder means it is going to sound. Sound means measure the depth. Measure the depth. Okay, how much the depth is there? So echo, which is returning back, that gives the measurement of the depth. The name, that's why it is echo sounder. Okay. How it works? Let's see. There is a block diagram of the echo sounder. Recorder, or nowadays, this recorder, we have a LED display or display unit only, we say this one. Olden days, there was a paper roll and there was a stylus. So it is going to mark on that one. But nowadays we have the display unit, much advanced one, LED display. Okay, so these displays are there nowadays. This recorder unit or display unit, that is also is going to have not only the display which is going to represent the depth, but it is also having a trigger unit. Trigger unit. Same like a radar, this trigger unit used for synchronizing the recorder display unit plus the transmitter and receiver also. So it is going to generate the trigger as per the depth selection. Depth selection. How much the depth we are selecting, as per that it is going to give the trigger. This trigger pulse, this will come to the pulse generator. Pulse generator will shape this trigger pulse into the transmitting pulse. It will shape it to the transmitting pulse. And it will be given to the transmitter. Transmitter means here the high voltage is applied. This high voltage during the time of the pulse, transmitting pulse, which is shaped by the pulse generator. A high voltage will be applied that will be given to the transducer. This energy will travel down to the seabed. So the transducer which is transmitting the energy, this is a transmitting transducer. It is a transmitting transducer. Not like a radar antenna. It is not like that. We have a different transducer. Transmitting transducer that will transmit the energy, whereas the receiver transducer, both are housed together only. Receiver transducer, this will receive the energy, it will give to the receiver. Here we have a various stages of amplification. Then we are going to have the detector, that is the video detector. Then we have the video amplifier, and this video amplifier will be given to the recorder or display where the LED is there. If the stylus is there, this video detector and video amplifier is not required. It will be given directly. It will be given directly. So this is how the echo sounder works. Echo sounder works. Okay, any doubt to anyone? Okay. Now, here one more thing is there. That is the power supply, how it is given to the navigation equipment. Now, we have already seen many navigation equipments are there. Okay, so how they are given except GMDSS. GMDSS is different. Okay, but that also similar only. But we'll see that is a different how it is given. So all the bridge equipment or navigational equipment, the power supply that is given. Okay, we'll see here, we'll try to understand with this diagram. Now in this diagram, if you see, there is a AC supply that is coming. This AC supply generally comes from a change over switch, COS. COS, this is known as a change over switch. Now changeover switch is will get the mains supply, that is the 220 volt from the MSV, and this is the emergency 220 volt from the emergency switchboard ESC. Always the mains will be connected, but in case if the mains is interrupted or disconnected, then emergency source of supply will be connected. So this is the changeover switch. Now this all will be rectified. So here you can see before the rectifier there is one filter. This filter, this is known as a EMI filter. EMI filter. What is the meaning of this EMI? Anyone?
Sir, electromagnetic interference.
Yes. Electromagnetic interference. So these filters will always be there wherever we are going to use the sensitive equipment, which are very sensitive to the interferences. Okay. Like your governor, main engine governor. There also we have the 24 volt supply. Before that, you will find there is the EMI. EMI card is there. Filter. Then this supply will go to the AC to DC converter. It will convert that one. And it will be given to the navigational equipment. So this is how it will reach to the navigation. All the navigational equipments operate on 24 volt only. Although we give the 110 volt or 220 volt, that will be converted into the 24 volt DC. Inside, there is a rectifier. So both supply is given, 24 volt supply plus the 220 volt or 110 volt. Now suppose if none of these are available, if 220 volt is not available, then this is the power, 24 volt power, this is a battery power. This is the battery supply. General purpose battery, GP battery we say. So from the GP battery, this 24 volt is always available and it will be given. Standby power supply, but it is not only the battery supply. If battery is powering, then battery supply, because mains and emergency, if it has gone, that means In the battery charging discharging board is also not going to work. The battery supply which is coming to this direct. So this is how the 24-volt supply that is given to the navigational equipment, nav equipment. All the nav equipment will be having like this configuration. Now, if any power supply that is failed, if it is failed here, you can see like AC, that is supply fails, this indication will come. If DC supply fails, this indication will come. We have the buzzer also will sound, buzzer stop or acknowledge one. Okay, so we can stop that one. There is a test button for the buzzer, this lamp, two indicating lamp and buzzer, so we can test that also. So this is how the circuit works. Okay, any doubt in this circuit, anyone? No doubt? Okay, I have one doubt. Why this one is provided here? Why this is provided? Anyone?
Sir, in case of this
Latching.
diode is get open circuited,
Yeah, it's latching circuit.
Sorry?
So it's some kind of latching circuit. If the diode is in problem,
Why latching circuit? It is nothing like a latching circuit or something like that. If you see here, this is the J1, this is the relay. J4, this is relay, and J2, that is the relay. If power supply is available here at this point, this will energize. That means this J1-1, this will be open. If it is the open, then this diode is working like a blocking diode. That means this supply from here, it will not go to this side. It will not go for charging to the battery. Okay, so this acts like a blocking diode. The other one. Same diode is here also, you can see, both are same. This is also the purpose of this. This is a blocking diode. Blocking diode. This diode, in case your charger here or battery is discharged or shorting, or here if there is a earth fault, then your battery, this supply will get discharged. Or similar way, this voltage will be going to that side and it will drop. That is the reason why this blocking diode is being used. So it will be here also, it is going to be here also. Okay, hope it is clear.
Sir, what do you tell about earthing?
Earthing, I am telling, earthing means if there is a earth fault, in that case, and there is no supply here, in that case, if it is powered by the battery, that will get discharged through this earth fault. That's why it is mandatory to put the blocking diode. Even in the charging discharging circuit, you will see these. Have you seen the charging discharging circuit, anyone? In that also you have the blocking diode of the battery charging discharging circuit. Have you seen? No. Okay. Uh, this is the battery charging discharging. So how I can rotate this? Rotation, I don't know about this one. You let me see if there is anything is there. Anyone knows how to rotate this?
Sir, I think so from this on the image, if you're clicking on the image on the top side in the center,
This
this square square. Yeah, this side, left side. On the left side is square, maybe.
no, it
No,
is
sir. Left center, sir. Left side center. Image, yeah, down, down, down.
nothing is given.
No,
No, it is not given. Okay,
yeah, it's not here.
so whatever, just go through it. Just I am making it little like this. You can see there is always the blocking diode that is being used. One is here, this one, DM1 you can see here. One is DM2, here also it is, you can see. The blocking diode always it will be there. Okay. The purpose of this blocking diode, so in case of earth fault, battery should not get discharged. There will be the blocking diodes. This is also charging, discharging circuit, emergency supply, normal supply, and this will go to the battery. When these supplies are not there, battery supply is given to the feeder. Different feeder. That is what the supply is coming here from the feeder. From the feeder unit, this supply is coming. They have their own 220-volt supply plus the feeder supply that is coming. So this is how it works. Any doubt to anyone? Tomorrow we'll see the GMDSS. There is a new regulation has come. I will tell you about that also because it is already with effect from 2024. They will ask you these questions. Okay, so be ready for that one. So we need to see that also. Okay. So thank you very much and good night to everyone.